Section 2.4, special functions and their graphs. So you should be working with this lecture guide, and first it goes over the linear models, and I'm not sure it goes over this, but I'll switch back over and we'll talk about that if it doesn't. So here are the linear functions, y equals 2x plus 1. If you put this in your calculator and press zoom 6, you can see what's happening here. Notice we have a positive slope and a positive 1 y-intercept. That's where it crosses the y-axis. Over here we have a negative slope and a positive 4 intercept, so that's why it's up here. And notice that the slope goes down from left to right. Y equals 5 is a horizontal line that crosses through number 5 on the y-axis. X equals -2. X is a vertical line when it's x equals. I think we talked about this once, and I talked about Buck's Hoy. If it's a x equals equation, then it's going to be a vertical line. If it's a y equals equation, it's going to be a horizontal line. So here where it says when the slope is positive, the graph increases from left to right. When the slope is negative, the graph decreases from left to right. When the slope is 0, the graph is horizontal, and when the slope is undefined, the graph is vertical. So on to the quadratic functions. We learned that quadratic functions were U-shaped. So if you notice here, this has a positive x squared term, so it opens up. This has a negative x squared term, it opens down. When a is positive, the graph looks like a smiley face. When a is negative, the graph looks like a frowning face. So the next ones are the cubics. And a cubic function has one arm going down and one arm going up.
It's okay. I say the whole weird thing too.
So the next cubic function, notice that it has a negative coefficient with the x cubed, and that it has one arm up and one arm down. But notice that it's the opposite way. So if it's coming from up from left to right, it's going to have a positive coefficient. If it's going down from left to right, or starting down from left to right, it has a negative coefficient. This one, notice that the coefficient of x cubed is positive because it's coming up, and this one is negative because it's going down from left to right. The inflection point is the place where the graph changes concavity. But basically that means that's where it goes from increasing to decreasing or decreasing to increasing. Quartic functions were the next one, and quartic is to the 4th power, and it's an even exponent, just like the x squared. It has both arms that are going up. The x squared looked like this, not very pretty, but You get the idea. Or like this, both arms up, both arms down. Cubic had one arm up and one arm down, and that's an odd exponent. Oops. Just like linear is an odd exponent, and it has one arm up and one arm down. So when it's quartic, it's going to have two arms up, and it might have something curved in the middle like this. It might have two arms down. This is also quartic, even though it looks like it's quadratic, it's still to the second power or to raised to the fourth power. This one, if you notice the coefficient of the fourth of x to the fourth, it is positive. This one, the coefficient would be negative. This one, the coefficient would be positive because the both arms are going up. Exponential functions, what you that is when you have the variable as the exponent, and it looks like this, or it looks like this, and the difference is the number that is raised to the x power, and that's how you can tell if it's a whole number, it's coming up. If it's a fraction, it's going down. Logistic functions, these are logs, and they look like this, kind of like a cubic laying sideways. Let me get rid of my markings. So this is a log function. Let's see what's on our paper if I'm missing anything. So exponential, b is called the base. For what value of b do you have a growth curve? So that would be a positive or a whole number value. For what value of b do you have a decay? That would be less than 1. The logistic model looks like this. And you're not going to have to do much with that, I don't believe. And all rational functions have an x in the denominator, is what that's going to be. So let's look at some rational functions. The PowerPoint. So rational is going to look like this, kind of where you have two graphs that go in opposite directions of each other. Isotope is a line that approaches the graph, a line that the graph approaches but never crosses. What that means is it's getting really, really close to the y-axis, but it's never ever going to touch it. This one's getting really close to the x-axis, but it's never going to touch it. This one's getting really, really close to this line, which is called an isotope. This is called an isotope. This is called an isotope. But this one, it's never going to touch it. It just gets really, 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 really close. Here's another rational function that has three parts. Oops. That has three parts to it. Notice the quadratic here. Quadratic. Radical functions, oops, look like this. And then you have piecewise functions, which this represents a piecewise function. You have a part that has a positive slope, a part that is a horizontal, which is a zero slope, a negative slope, and then another positive slope. This one says if f of x is 2, so y equals 2, if x is less than 0. So that's why you've got an open dot here, because it doesn't equal it. And then this part, x cubed, this is part of the cubic function. The rest of it would come up and around, but it's only talking about a piece of it, and it's only the piece that is greater than or equal to 0. An absolute value function is a V shape. And you can see that if you add something to it, it moves it over left or right. This is a piecewise function. So here it says, find k of negative 0.1. Well, negative 0.1 is less than x. It's less than 0. It's not between 0 and 1. It's not greater than or equal to 1. So I have to use this function to answer this. So this one just says that it's going to equal 2. And this means that we're talking about case 1. There's 3 cases here. There's 3 different pieces to this function. So here we look at k of 0.1. Well, that would be between 0 and 1, so we're going to have to use this, which means we put 0.1 in place of x, and then we add 4. So that would give us 4.1. Here's 0.9. Well, 0.9, again, is in between here. So if we say x plus 4, or 0.9 plus 4, we should get 4.9, because we had to use this case. 1.1 is greater than or equal to 1, so we have to put it in here. So 1 minus 1.1 is negative 0.1, and the absolute value of that would be 0.1. So it's this case right here. Alright, so I'm going to come here and work some of this with you without talking about it, just to make sure that it makes sense. So if you understood this before, then you can stop the video now. If not, I'm going to explain this one a little more. So here it says f of x, or k of x, equals 2 if x is less than 0. K of x equals x plus 4 if our x value is between 0 and 1. And k of x equals this if our x value is greater than or equal to 1. So we look at our x value. It is less than 1, so I have to use this function, and it just tells me that it's going to equal 2. And I'm done. This one, 0.1, is this one. So I have to use this, so I'm going to put 0.1 in place of x, plus 4, and that's where I get 4.1. That's a 1. 0.9 would be, again, in this one, and I have to put it in place of x, and that's where we get 4.9. This one is 1.1, so it's greater than 1, so I'm going to put it in this one. And that would become negative 0.1. And the absolute value of negative 0.1 is 0.1. So if you have any questions, ask me in class.